Why would I need AI in my data center? When adopting AI, your building progresses from a level 4 to a level 5 on the data center maturity curve, taking you from advanced automation to fully autonomous. But what's really the difference and what does it mean? Recent events have forced us to rethink how we manage our day-to-day operations. With limitations on having staff on site, data center operators have depended more on leveraging technology. From remote monitoring and deeper understanding and usage of their BMS or DSIM investments, they are also looking beyond automation to AI. There's often confusion between the differences in automation with advanced programming and artificial intelligence. Automation requires human intervention and additional programming when incorporating changes not already set within the parameters. With AI and machine learning, when conditions change outside of these parameters, the system recognizes the changes, learns, and adapts all on its own. To demonstrate this key difference in AI, we will review the complexity with cooling. Here's a layout of an actual data center customer. This is a typical data center with 30 computer room air handlers, or CRAHs. All are 100 kW units on a raised floor. Our white space cooling optimization, or WSCO, uses IoT technology to provide a dense network of sensors that continually measure temperatures at the rack level throughout the space. When I select a CRAH unit on the map, I can see that unit's influence in the environment. When this CRAH unit is turned on, we see the cooling effect in the space. But notice that these racks are hotter. This means that when this unit is turned on, it also creates a heating effect on some racks in other areas of the data center. In this case, the heating influence is happening directly in front of the CRAH unit when you would think that the result should be just the opposite. There are many reasons that this could be happening. This CRAH may be fighting with other CRAH units. The airflow of this CRAH may cause mixing or turbulence at the rack level. There could be obstructions under the floor that cause pressure differentials. Every CRAH unit in this data center has a different influence in the space. Understanding the airflow in the space is not always obvious. Some units only affect the racks next to them. Some CRAHs don't provide any cooling in the data center at all. This could indicate that maintenance is required, but in the meantime, the unit may be running, wasting energy with the problem going unnoticed. Then you may have other CRAH units that are critical to the cooling operations in the data center. The airflow patterns for each of these CRAH units and how they affect temperatures at any given time are impossible to predict. This is why cooling is difficult to manage. As an operator, you would expect that turning a CRAH unit on lowers temperatures in the data center, but the reality could be very different. This is the shortfall of using manual methods or basic control to manage cooling. Neither method understands the complexities of airflow in the data center. Add to that our increased demand on technology, creating unprecedented spikes in IT load. This extra demand has IT departments adding or changing the equipment or the layout. As we saw in our example, every change will have an impact in the space. Many cooling systems today monitor by zone. Some more advanced systems have sensors at the rack level to monitor temperatures and send an alert when detecting an issue, but that still requires a physical inspection with someone deciding a course of action. This could include experimenting with moving some floor tiles or cranking up some of the CRAH units. As facility managers, you are then reacting to what is happening, and troubleshooting techniques are largely based on assumptions using trial and error. The alternative is to leverage IoT technology and artificial intelligence to unveil all the complexity that exists and address potential issues before becoming a problem. AI with machine learning collects that granular data in real time, knows exactly what is happening while it's happening. It can anticipate a need. It assesses the best course of action with its understanding of all levels of cause and effect. It then makes an informed decision, executes it, and verifies the outcome. Once AI has been implemented at your site, does this mean that the job is done? Well, not exactly. This is where you now take your operations to yet another level. All those IoT devices that feed information for an AI engine to make decisions and send commands now allows you time to leverage and analyze the data collected to find additional ways to better manage the facility. Check out some of our examples for how customers have already invested in AI and have identified opportunities to help achieve operational excellence.